Hello and welcome to this Patent Academy tutorial about TLS configuration for Microsoft Teams with Patent SBCs. In this video lesson, we are going to cover the necessary procedure to generate the TLS certificate for encrypted communication with Microsoft Teams. We would like to remind you that an excellent chapter to read before you start can be found in the Trinity Command Line Reference Guide. It is the chapter on TLS configuration for SIP. Here you have all the details and all the conditions that must be met before you configure TLS. And here in this lesson, we are going to cover the necessary commands that will lead you to a successful TLS configuration. So let's begin. Here are the topics we will cover. Generate the private-public key pair on the device. Then we will generate a certificate signing request, or CSR, and after that, in the third step, we will export this request. And then we'll send it for approval and signing by the Certificate Authority, also known as the CA. The fifth step will be the import of the signed certificate that we have received from the CA to our patent SBC. And finally, we will have to link this certificate to the TLS profile on our SIP gateway for Microsoft Teams. So to begin, we start with first creating the necessary TLS profile. Let's create a profile of type TLS with a specific name that identifies it as our Teams profile, PF TLS Teams. We recommend that you not use the default profile, the default TLS profile that is already available on a patent device, that is, for MS Teams. The default profile is best used for automatic provisioning with Patent Cloud. So in order not to mix those two TLS profiles together, we prefer creating a separate dedicated TLS profile for Teams. Okay, so this is how it looks. Now we have to add some preliminary commands before we go on with the private key and certificate request. We have to add the compression. We have to also say no protocol TLS version 1.0. and no TLS 1.1 in order to actually force the TLS version of 1.2, which is required by most carriers and also by Microsoft Teams. Okay, we also have to change some Diffie-Hellman parameters and put the default 4096 here. And finally, we have to enter the command require certificate type server. So these are the basics we need to enter before we go on. Now we will start creating the private key. So the command is generate PKI private key. Note the syntax and where colons and forward slashes are needed. And we will give it a name which will be composed of the FQDN of this session border controller with the extension .key at the end. So we type the FQDN of this device, like so, and then we will add .key at the end. It's important to note that Microsoft will contact this SBC using this fully qualified domain name. The next parameter is the key length. Most certificate authorities require the private key size to be at least 2048 bits. So we will put here 2048, and that is all for this command. Press Enter. And this takes a few seconds. And now the private key has been generated, and the device has also automatically created the related public key. So we have generated with this single command the key pair on the device. Now, the next step is the generating of the Certificate Signing Request, or CSR. And this is done also with the command generate PKI. We say certificate request, we call it request 1 here, and note that it doesn't have to match the FQDN, you just have to give it a file name. And then very important here, it must be related to the previously created private key. So we type private key with the exact same path as before. And we can use the help with the tab key here. Okay, this is the previously created key. Then the next parameter is the country. We are recording this lesson in Switzerland in the test lab at Patent. State, Bern. Locality is also Bern. The next parameter is organization. We can say test lab. Of course, you would have to put your exact organization or department name. The next one is organization unit, which we can make VoIP. It has to match your internal company organization with your department name. And then we have common name. This is the most important parameter because with common name, you have to put the exact domain name of the session border controller, which will be exactly what we entered earlier. It is this here, but without the extension .key. So we can copy and paste this. Okay, so we are good to go with this command. Enter. Now the certificate signing request has been created. The next step is to export this CSR request that has just been created. And this is very simple with the command export and with the path to the certificate request. Now this output has to be sent to the certificate authority. One way is to copy-paste this into an editor. You have to copy the whole part starting here on the begin certificate request line up to the end certificate request line. Let's do this now with our editor. Good. Now there are several methods you can use. Either copy it like this manually, or you can use the copy method with copy to a TFTP server from your SBC device, or you can also use the web GUI to download the certificate request. Let's also look at the method using the web GUI. Under the PKI menu, choose Certificate Request. So our request 1 is here. From here we can click Download and download it to our computer, and then send it to our CA. Then the next step takes place once we have approval and signing by the certificate authority. After the CA approves the certificate request, it signs it with its own private key and returns the issued signed certificate in one of the usual file extension formats, which are .cer, .crt, .pem, or .p12. Certification involves multiple files, a certification chain, if you will, which consists of the certificate itself and then some number of intermediate certificate authorities. Here we will have one intermediate certificate authority, but you can have several, and then the certificate of the root certificate authority, which is CA root. So here in our example, we'll show you what Microsoft has sent us, because Microsoft was our CA. We received the certificate itself in the form of this FQDN name with a .pem extension, and then an intermediate certificate, and here we'll just show a dummy file. We of course don't want to show the whole content of the file, and then we have the root certificate. So the certificate authority that has been used in our test is the one provided by Microsoft, and Microsoft returned to us these 3 certificate files. We have one certificate corresponding to the device itself, which is this one. It is encoded, so it doesn't help too much to decode this, but we'll see it afterwards, after import. Then we have the intermediate certificate, here, and we have also the root certificate, here. And all 3 files here in this particular example have been provided to us in the .pem file format. And as we said earlier, there are several possible formats. PEM is not the only one. You can also have CER, like the word certificate, or CRT, also like certificate. All right, let's continue. So let's import these certificates into the SBC by using the web GUI here. Here we are already logged in, and we will start from the main menu, where we will choose the Management menu item. And in the submenu, we choose PKI, which is Public Key Infrastructure. And here in the PKI window that opens up, we have different menu items to choose from. We have private keys, which list the private keys on the device, but as we said earlier, private keys are not displayed for security reasons. We have the public key here, which we generated earlier. We have certificate request listed here. Here is our request that we made earlier. And under certificates, there is only the default certificate, which is loaded in the factory at patent. So now we have to upload our certificates that we received from the CA. Before we do this, let's take a moment and mention that here under Trusted Certificates is where we would have certificates to be trusted that we have imported ourselves. And under Trusted Certificate Defaults, we have all the default trusted certificates that are loaded in the factory. Okay, let's come back to certificates and let's upload our certificates that we received. Click on this plus sign to open the Add Certificate window. And by the way, we can see here that in addition to using the CLI, it is possible to generate the private key for a CSR request here using the web GUI. But right now, to add a certificate, we want to click on File. And then let's browse to where our files are stored. We've put those 3 files in this particular folder. Let's take a moment and discuss the fact that we have 3 files here. Why not just one? It has to do with the principle of the chain of trust. This is what has been implemented here. So how do we consider our CA as trustworthy? In the model of the chain of trust, the root CA is at the very top of this hierarchy. The root CA signs all certificates with a single private key. This entity is the highest signer. It publishes a so-called self-signed certificate. A self-signed certificate is created by using its own key to verify its own identity. Intermediate CAs have been conceived to distribute the trust model. Instead of having a single CA in the hierarchical trust model, the distributed trust model has multiple CAs that sign digital certificates. So in this model, the authority is delegated to other intermediate CAs to sign these digital certificates, and their role is similar to saying, I concur that the root CA is trustworthy. In our case, this is the Microsoft Corporation. And then we have the signed digital certificate for our SBC. Let's upload the one for our device. Select it, and click Open to choose it, and then OK in our dialog window. We see that the issuer is Microsoft. The owner is also Microsoft, despite the fact that we sent our own country code, O plus OU, in the CSR request. This was overwritten by Microsoft. But the most important attribute, the CN, or common name, was kept and corresponds to the SBC domain name. This must match exactly with the domain name that will be used in the communication with Microsoft. All right. Now let's upload the other 2 files, starting with the intermediate one. So this is the intermediate CA that signed our CSR request. The issuer is Baltimore, and the owner is Microsoft. So now let's add root. And we click on that so we can have a look at the imported root certificate. We mentioned just a moment ago that the root authority is the highest link in the chain, and that they self-sign their own certificate. And that is what we see here. The issuer and the owner are identical. Okay, now we have just a few more commands to enter here at the command line to complete our profile. We have to say private key, because this is still missing, private key, and then we have to refer to the exact private key we used before with our CSR request. So, private key, PKI, and then the path and file name of our .key file. And now let's add the own certificate information, which is own certificate, PKI certificate, and then the .pem certificate file that corresponds to the SBC itself. And then we add the intermediate, and finally the root certificates. So we can hit the up arrow key to repeat that command. All we have to do is change the file name at the end, ca1.pem, enter, and then do that again, changing the file name to root.pem, enter. There, now all 3 certificates have been entered. Let's save this configuration, and then copy running config to startup config, since we've made all these changes. Do a show running config, and this is how our profile looks. And now we also have to use this profile in the context SIP gateway, which is here, the one with the name Teams. Okay, we see that the context is bound to the location service Teams, as explained in our configuration guide, and at the moment it's shut down. We will change that to no shutdown when we are ready to activate this context and get the configuration running. So let's put here use profile TLS Teams. We can show running config again. That looks good. And now, since we want to be sure that it's running correctly, we would also like to debug with debug all SIP full detail. And now let's activate the gateway with no shutdown. Okay, I will stop the debug mode. Let's come back up here. So our configuration actually resolves the remote peer, which in the case of the Microsoft Test Lab is sip.pstn hub-ppe.skype.net. And this is being resolved to this IP address. And then before the SBC sends the first options ping, the TLS communication is being set up. And there is a TLS handshake process being done here. And we see here the TLS certificate of Microsoft. There is a TLS handshake approval. And we see that we are sending the SIP options ping to Microsoft using SIP over TLS. This is a good sign. In fact, it is the proof that our TLS connection is working. We received a 200 OK, also through SIP over TLS. And again, there is another TLS connectivity set up from Microsoft to the SBC. And we received the options ping also using TLS transport here. And we answered this with a 200 OK, also using SIP over TLS. And there you have it. And that concludes this video tutorial and walkthrough on the process of how to configure TLS. Thanks for watching.